All right. Hey, ladies and gentlemen, this is Miss Humbert, and today we're going to be doing Unit 5, Learning Target 3. So today we're going to be talking about graphing applications, why we're graphing things, what that's going to tell us, and a lot of this is going to make a lot more sense as we move forward in the unit. So first off, let's talk about the x-intercept. So I do want you to write this stuff down because it's important to reference back later. So the x-intercepts are where a graph touches the x-axis. Now remember that the x-axis is the horizontal one. It's also known as the solutions, zeros, or roots of the quadratic. Okay, now all of those words are going to start to make more sense throughout the rest of this unit, but we're just going to start with graphing because that's what we're familiar with. Parabolas can have 1, 2, or no x-intercepts. So we're going to start today by just looking at parabolas and figuring out how many x-intercepts they have. So let's start by taking a look at this one. So before we can figure out how many x-intercepts it has, we have to calculate out the vertex. So we're going to use that formula x is equal to opposite of b over 2a. So remember, b is always with the x term, so we have opposite of b over 2, and a is always with the x squared term, and since there's no coefficient, it's just going to be 1. So then we get negative 4 divided by 2, which is negative 2. So the x-coordinate of my vertex then is negative 2. So remember, I put that in the center of my chart. So now I need to plug that back in wherever I see an x, and that's what's going to give me my y. So y is equal to negative 2 quantity squared plus 4 times negative 2 plus 3. And remember, you can plug it into your calculator just like that. Okay, and that will spit out your answer. And when you do that, you end up with negative 1. So now in order to graph this, we need to fill out the rest of our chart. Well, I'm going to get bigger going up this way, and I'm going to get smaller going up that way. So now I'm going to go ahead and I'm going to plug in those x values for x, so I can get my y. So I'm going to plug in negative 1, and so wherever I see an x, I'm putting in a negative 1. Again, it's always good to be calculating this along with me so you make sure you know what you're doing. So when you plug this into your calculator, you end up getting 0. So we have 0. Remember, it has to be symmetrical on either side. Continuing on, let's take a look now at, let's plug in 0. So we have y is equal to 0 squared plus 4 times 0 plus 3. So now we're going to plug that into our chart, so we end up with 3 for each of those values. Now let's graph this. So for the vertex, we're going left 2, down 1, and plotting that point. And through that point, we have a vertical axis of symmetry. Then we have negative 1, 0, and negative 3, 0. So we're going to plot each of those points. Then we have 0, 3, and negative 4, 3. So that gives me my parabola going up on either side, and it should be symmetrical. So what I notice is that it's crossing the x-axis twice, here and here. So it has 2 intercepts, and those intercepts are going to be at negative 3 and negative 1. Now, let's take a look at number 2. So for number 2, again, we're going to calculate out the vertex. So I'm going to use that x is equal to opposite of b, so x is equal to opposite of b over 2a. So that's a 0.5. Remember, you always want to simplify the bottom before you move on. So you end up with your x-coordinate as negative 1 for your vertex. The x-coordinate of your vertex is negative 1. Now we're going to plug that back in so we can get y. So what I'm doing is I'm plugging in each of those values for x. And I end up getting 1.5. Decimals are okay. We'll look at how to work with them here in a second. So now I want to plug in the rest of my values. Well, I'm going to go upwards here, and I'm going to go more negative here. So let me plug in 0 to start off with. So when I plug in 0, I end up with 3. That's for this one and this one. Next, let's plug in 1 and see what we get. Remember, it needs to be symmetrical on either side. And that's what will give us our y. And when you do that, you end up with 5.5 on either ends. So let's go ahead and graph this. So we're crossing at negative 1 and then 1.5. So I'm going to go up to 1 and then I'm going to go halfway to 2. And that's going to be my vertex. Then I'm going -2 up 3 and 0 up 3. I'm also going over 1 up 5.5, so I'm going to go halfway to 6. And same thing over here, halfway to 6. So this right here represents my parabola. So here I'm noticing that it doesn't cross the x-axis at all. So this has no x-intercepts. No x-intercepts. All right, let's take a look at that next problem. So we want to graph this. So to start off with, we need to calculate out our x-coordinate of our vertex. So that's going to be opposite of b over 2a, which is going to give us -4 over 2 times 1, which is -2. So now we're going to have to plug in some values into our vertex or into our equation. So this way we're going to get more positive, so we have -2. This way we're getting more positive. This way, more negative. So let's plug in -2. So we have -2 squared plus 4 times -2 plus 4, and that's going to give you 0. And then we can plug in -1. So now I'm just plugging in -1 wherever I see an x, and that gives you 1. Again, I've pre-calculated these out. I suggest calculate them out so you make sure that you can do it correctly. Now I'm plugging in 0 for x, and I get 4. So I'm going to go ahead and graph that. -2, 0 goes here. Then -3 is going to 1, and so is -1. And then 0 up 4, and -4 up 4. Remember, through the vertex, we want to draw our axis symmetry, and so that is going upwards. Now, if you notice, our vertex is sitting on the x-axis. So that means we have one intercept. And if you notice, we're crossing the x-axis at a -2. So our one intercept is -2. Let's take a look at some applications. So the equation y is equal to -x squared plus 4x plus 3 represents the height y of a flying disk x seconds after it's tossed. When will it return to the ground? So when we throw things, that can be represented by parabolas. So I know this seems really confusing right now, but all we really have to do right now is just graph like we normally do. So first we're going to calculate out the vertex. So we're going to do opposite of b over 2a. -4 divided by 2 times -1 is -2. -4 divided by -2 is 2. So our vertex is 2. And then we're going to go up this way, and we're going to go down this way. And now we need to plug in our different values. So let's start by figuring out the vertex. So to get our y, that's going to be equal to negative. Now remember, you put that negative on the outside of the squaring. Notice how my parentheses are after the negative. That's because it needs to be a -x squared. So you're going to plug this into your calculator exactly as is. And when you do that, you end up getting 7. So your vertex is 2, 7. Next, let's plug in our next point, which is 3. So you can plug in 3 in for x exactly like I did for 2. Again, plugging that in exactly into your calculator how it's written here. When you plug in 3, you get 6. Again, I do suggest trying this in your calculator, making sure you're on the right track. So now we're going to take out the 3, and we're going to put in 4. So now we're going to do 4, and that gives us 3. So for starters, let's go ahead and let's graph this before we worry about the word problem itself. So we're going over 2 and up 7. That point represents our vertex. Then we have our axis of symmetry going through it. Then we're going over 1, up 6, and over 0, up 3, over 3, up 6. Again, just graphing the points from my table. Over 4, up 3. So we're going down this way and down this way. So this represents that rock being thrown. We're starting here, we're throwing it up, and it's coming down. The x-axis always represents your ground. So the x-axis represents your ground, and to me, it's looked like it's crossing the ground at about 5. So since it's crossing, it's hitting the ground at about 5, that means since x represents seconds, that means that after 5 seconds, that disk has hit the ground. So all I did was figure out when it crossed the x-axis, and that x value tells me how many seconds it took to hit the ground. Not too shabby. Let's take a look at a couple of other examples. So let's take a look at this one. We don't have to graph it, but we're going to use our graphing technique to calculate some stuff out. A baker has modeled a monthly operating cost for making wedding cakes by the function y is equal to 0.5x squared minus 12x plus 150, where y is the total cost in dollars and x is the number of cakes prepared. So first part, find the axis of symmetry and vertex. I can do that. So x is equal to opposite of my b, so b is going to become a positive 12 over 2 times a. So then that's going to end up being 12 divided by 2 times 0.5 is just 1. So then I get 12. So the x-coordinate of my vertex then is 12. So now I need to take this 12 and I need to plug it in for each of those x's. So then I get 0.5 times 12 squared minus 12 times 12 plus 150. Again, you don't need to break this into little pieces to solve it. If you plug it into your calculator exactly how I have it written, you'll get the right answer. And when you plug it in, you get 78. So our vertex then is 12 and 78. So when we're talking about maximizing and minimizing cost, the minimum cost is always represented by the y-coordinate of the vertex. So what is our y-coordinate of the vertex? Well, it's 78. And we want to figure out what the cost in dollars is, so I just need to label it $78. Then when we're talking about how many cakes we need to prepare, that comes from the x-coordinate of the vertex. And the x-coordinate of the vertex, if you look up top, was 12. So if we prepare 12 cakes, we will minimize our cost at $78. You know you need to use the vertex to calculate things out when it uses the word maximum or minimum. Let's take a look at a car dealership. So it gives us a quadratic, and it says it models the total cost in dollars, and X is the number of cars worked on. So this is really similar to number 5. We want to find our minimum cost and how many cars we need to get there. So first let's calculate out the vertex. So we're going to do opposite of B, so that's going to be, since it's a negative 12, it's going to be positive, divided by 2a. Well, it's 0.25, so 2 times 0.25 is actually 0.5. 12 divided by 0.5 is 24. So now we know that x is equal to 24. So where I see x up here, I can plug in 24. So I get 0.25 times 24 squared minus 12 times 24 plus 200. Again, you can plug that exactly into your calculator as I have it written. And when you do that, you should get 56. So our vertex is 24, 56. Now part B asks for the minimum cost. Now remember that the minimum cost comes from the y-coordinate of the vertex. Well, the y-coordinate is 56. So the minimum cost then is $56. Part C, how many cars should be worked on each month to yield the minimum cost? Well, that comes from the x-coordinate of the vertex, which is 24. So we're going to work on 24 cars. So these two right here are your final answers for A and B. So that concludes your note video today. Go ahead and show me your completed note sheet when you're done. Thanks for listening.